Good day, ladies and gentlemen. My name is Andrew McNally from IMS Engineering, and welcome to Multotec's training workshop focusing on fines processing. This session will deal with the use of various crushing technologies to maximize or minimize the fines in your process. There are several methods of comminution. Comminutions of solid materials requires different types of crushers or mills depending on the feed properties of the material fed to the machines, such as hardness, feed size distribution, and in addition, the forces applied by the machines onto the solid feed material. Comminution occurs in stages, typically primary, secondary, tertiary, or even quaternary crushing and grinding. Simplistically, materials' resistance to mechanical stress imparted on it can be described as hard, medium hard, or soft. And the different types of mechanical stresses implied onto the material can be defined as compression, shearing, impaction, and attrition. The different types of crushing technologies you would use to treat the various types of material, either being hard to soft or dry and moist or plastic, depends on that feed material. Jaw, gyratory, and cone crushers typically are used in hard materials and hard and abrasive materials, while impact type crushers are used on soft non-abrasive material. If we compare the different types of crushing technologies based on the mechanical stresses they employ, we will see that jaw, cone, and roll crushers primarily make use of compression crushing and some shearing, while the impact type crushers, being the impactor and hammer mill crushers, primarily use impact crushing with some shearing in the hammer mill. The design of the different types of crushers and the mechanical stresses they use, you end up with a product with different properties. For jaw crushers, they produce very low content of fines and a flaky product. This is due to the geometry of the crushing chamber. While cone and gyratory crushers also produce a low percentage of fines, however, the shape is improved compared to a jaw crusher. Roll crushing technology or sizer technology produce the lowest content of fines. However, the shape is much more improved compared to the other types of compression crushers. One moves on to impactor and hammer mill crushing technologies. Both produce a very high content of fines with a good cubical shaped product. And because the impact forces exploit the inherent cracks in the material, they're very good at exposing the minerals in the material and helping with liberation. Hammer mills have the additional advantage that due to the fact they have a grate installed on the outlet, you can limit the maximum product size.
Moving on to primary gyratory crushers. Primary gyratory crushers are generally used in large open pit operations and occasionally underground, more specifically in block caving or mining applications. They're designed to accept very large feed sizes where the feed material is hard and abrasive and can operate at reduction ratios of between 3:1 and 6:1. It is generally only economically viable to select primary gyratory crushers for capacities of more than 800 tons per hour, and there are many operations where the feed to the primary gyratory is in excess of 10,000 tons per hour.
If we move on to the typical assembly of a primary gyratory crusher, the crusher has an oscillating main shaft, which is supported at the lower end on a hydraulic cylinder on a ram, and at the upper end in the spider arm by means of a bush or a bearing. The eccentric shaft is rotated by a gear and pinion in the eccentric sleeve, which produces the oscillating or gyrating movement, which then transfers the forces onto the material, which is now flowing down the crushing chamber. This then reduces the particle size distribution, and it is discharged through the open side or closed side setting. Primary gyratory crushers do not produce a high percentage of fines because they are slow moving machines and operate at large settings. The main function is to reduce the material so that it can be conveyed to downstream crushing or processing operations. The majority of fines in the final product would be inherent in the raw material. Jaw crushers are also selected to process hard and abrasive run-of-mine material, are generally installed above or below ground for applications up to 1,000 ton an hour. The reduction ratio is also between 3.1 and 5.1. And although they can accept large feed size, it is generally best case practice to control the top size by some sort of static grizzly. A jaw crusher is made up of a frame which has a stationary jaw plate, and then a moving jaw plate. A moving jaw plate is on a swing jaw which has a eccentric shaft. As it rotates, oscillates, creating the compression forces in the crushing chamber. There are two different types of jaw crushers, namely single toggle and double toggle. In a single toggle, the eccentric shaft is at the top of the crusher, and the shaft rotation and the toggle plate cause the compression action. This is seen in this animation. For a double toggle, there are two shafts and two toggle plates. First shaft is a pivoting shaft at the top of the crusher, and the second shaft is a pivoting shaft, eccentric shaft, that drives both toggle plates. This creates pure compression, and because of its pure compression with not much attrition, this is generally used for even harder abrasive material than one would normally use it for a single toggle. If we move on to cone crushers are generally used in secondary, tertiary, or quaternary applications where you need to process hard abrasive material. Depending on the hardness of the material, the reduction ratio can be up to 6.1. And there are a huge range of cone crushers that can process from very small throughputs, 80 ton an hour typically, to in excess of 1,200 tons per hour, dependent on the model and close site setting used. An interesting concept for cone crushers, they can operate as wet or dry systems. If you're processing very sticky, moist material, water can be added to the system to scrub out the difficult to treat material and allow the crusher to crush down the competent part of the feed material. If you look at the cone crusher assembly, there are various designs. The design we are looking at now is a machine that has an oscillating shaft that is also supported at the bottom on a hydraulic cylinder and at the top in the spider arm. And as with the primary gyratory, the gear rotates the eccentric sleeve, which then creates the gyrating movement in the crushing chamber. As the main shaft gyrates, the energy is transferred into the material in the crushing chamber, and the material then, the size is reduced and it passes through the crusher. The crusher should be operated at a choke feed level. This allows an additional force to be imparted on the material, namely interparticular crushing, which also assists in this reduction of the size. A different type of crusher that makes use of compression crushing or roll crushers and sizers. These are ideally suited to crush soft or medium hard material, but specifically where the end user is looking to require a low percentage of fines. And they're also very effective when crushing wet, sticky material, generally used in limestone, clay, coal type applications. You get various different types of sizes. You get center sizes, which are used in primary crushing application where the two rolls turn towards each other. If you have a different tooth arrangement or different roll arrangement, you can also use the center sizer in a secondary application. And there are also side sizes where the two rolls turn in opposite directions and crush the material against wear liners in the housing of the crusher. If we focus on the roll crusher, the two rolls run towards each other and the feed is nipped between the rolls and the teeth, is then pulled down through the gap, and compressive forces act on the material between the rolls and the teeth shear the material. This video clip will demonstrate the principles of roll crushers. You can see the material being drawn through the rolls. You'll notice that the fines do not necessarily need to be scalped out, and this allows for a high capacity machine. Sizers also have a similar operation. We have two rolls operating towards each other. You'll notice the teeth arrangement is different compared to a roll crusher. And the feed size to these machines can be really large. And then as with a roll crusher, that's not necessary to scalp out the fines into the machine, allowing for a very high capacity crusher with a small footprint. Impact crushers, as the name implies, make use of impact when crushing feed material. Impact is simplistically made up of a housing, which has liners, wear liners, impact aprons, and a rotor with blow bars. The advantage of an impact crusher is that it can operate at extremely high reduction ratios, and the range of impact is from really small machines that can have low capacities to really large primary impactors that can accept huge feed sizes and produce small fine particles in one pass. It should be noted that impact crushers should only be used for non-abrasive material. As you'll see, impact crushers are very flexible, and settings that can be adjusted while the crusher is operational allow it to either increase the amount of fines in the downstream operation or reduce the amount of fines. The principle of impact crushing is that the blow bar strikes the feed material, and the material is then impacted onto the impact aprons and returned into the path of the rotating blow bars. So this video clip is taken inside a impact crusher and demonstrates this. You will notice that most of the comminution takes place when the blow bar strikes the feed material, and then as the material returns from the impact apron, it then gets reduced further.
So what happens when the gap setting on impact crusher is adjusted? If one follows the path of material entering an impact crusher into being struck by the blow bars against the apron feeder, you'll see that once the aprons are adjusted, the frequency that the particle is returned into the path of the rotor is adjusted. At smaller gap settings, the particle size distribution of the product will be finer. As one adjusts the apron feeder settings and the gap, the amount of fines is reduced and the product becomes coarser. Another setting that has a big impact on the product size distribution is the rotor tip speed. At higher tip speed, a higher percentage of fines is produced, and as one slows down the rotor, this has the opposite effect of producing a coarser product.
The next type of crushing technology that uses impact crushing is a hammer mill or a hammer crusher, which are used for fine crushing or milling of medium hard to soft non-abrasive materials. The hammer mill assembly is made out of a housing and a rotor. The rotor has oscillating hammers attached to it, and there are various designs. This is an example of a single rotor design, and this is an example of a double rotor design. You'll notice that on the outlet of this machine, there are grates which retain oversize in the machine, in the crusher, until they've been reduced to their required size, and they will pass through the grates. So the top size control is very good with these machines. It is also very flexible machine when it comes to the product size distribution that your operation requires. If you look at curve number 1, the crusher is running at a low rotative speed using a 6 millimeter grate. If you compare curve number 3, it's the same machine, but running at a higher rotative speed, crushing over a 2 millimeter grate. As you can see, this one machine can produce a large envelope of products as your process requires. The next stage of this presentation, I'd like to discuss a case study specifically about an operation that needed to minimize their fines. There's an iron ore operation whereby they supply their main product is -25 +8 lumpy iron ore. The reason they would like to minimize, they define -8 in this operation as fines, as they receive a price premium for the lumpy ore from their final customer. So when they plan to expand their operation, one of the main objectives was in the tertiary crushing stage to maximize this lumpy ore and minimize the fines. The red curve was the particle size distribution achieved from the existing crushers. You'll notice there's quite a significant amount of fines in that product size distribution. And the aim was to reduce the oversize to ensure that in one passing they have as much -25, but not increase the amount of fines, actually reduce the amount of fines. So obviously it's hard iron ore. They would need to use cone crushers in this crushing stage. The idea was then to come up with a solution to optimize crushing chamber to maximize the lumpy ore. So what can be done to maximize the lumpy ore in a cone crushing application? How to make a steeper product size distribution? So one thing is to look at the surface of the crushing plates. If the mantle and the concave, the wear liners have a grooved surface, this results in a steeper product size distribution. The shape of the crushing chamber plays an important role. If the crushing chamber is curved, as opposed to a linear crushing chamber, the product size distribution is also much steeper and fines are minimized. In addition, the inclination angle of the crushing chamber plays also an important role, as this helps to produce a steeper product curve. The end result of using an optimized crushing chamber was that the crushers with the optimized crushing chamber produces a 15% -8, where the conventional crushers employed in the existing plant produce, at the same setting, produce 35% -8. So obviously there is 20% more lump ore being produced that the customer can sell at a premium. In addition, one of the focus areas in this expansion project was to reduce the amount of flakiness in the product. So in other words, produce a product with a good cubical shape. The reasons for this is, the primary reason is to minimize product degradation and resultant creation of fines during handling. It's obvious that if you have a flaky product, it degrades during material handling, and obviously most iron ore producers are far away from their customers, so there's multiple handling through stacker reclaimers, trains, ships, loading, offloading, giving the opportunity for flaky product to degrade into a fine product, which then ultimately the customer would be paid a lower price compared to the premium -25 +8 product. In addition to this, product with a good shape improves screening efficiency and improves the beneficiation, downstream beneficiation, be that DMS or jigging. So by employing the same optimized crushing chamber, it was shown that the product size distribution had a flakiness index of 3 times lower than a conventional crusher. This results in a product that doesn't degrade during handling and ultimately a higher price for the customer. I'd like to thank you for your attention.